Hey, also, this is 8.1, and it deals with polynomial functions. So we're going to start off with a lot of definitions, and some of these definitions are going to help you in the support part of this also. So first thing, I'll define polynomial. All right, let me be letting people in. All right, so a polynomial is an expression made up of one or more terms. The terms are separated by addition and subtraction. All right, let me let a few in real quick. All righty, so I'll give you an example of three polynomials. A monomial, a binomial, and a trinomial. So a monomial has one term. Binomial has two terms. And a trinomial would have three terms. All right, y'all, so let me give you an example of a monomial. That could be something like f of x equals 3x. A binomial would have two terms, so that could be a x plus 5, x squared minus 3. Anything with two terms would be a binomial. And in a trinomial would be something like 5x squared minus 3x plus 4. So the monomial had one term, binomial 2, trinomial 3. All right, so the next definition. Degree. So when we talk about the degree of a polynomial, we're talking about the highest exponent of that polynomial. Now, most of the time they're going to be in descending order by those exponents, but be careful. Sometimes they like to switch them up on you and trick you up on that degree, but you always want to find which term has the highest exponent for that degree. Leading term, this will be more in the support homework, but the leading term is the term that contains the highest exponent. So if I was looking at this example of this trinomial I'll put here, the leading term of this expression would be the 5x squared term because it has the highest exponent. So the leading term is the number and the variable with the exponent, okay? They got what they call a leading coefficient. The leading coefficient is the number in front of the leading term. Now remember, the leading term contains the highest exponent. So if they're out of order, you got to find the highest exponent to get that leading term. So the leading coefficient is the number in front of the leading term. So y'all, what if you had something like, okay, so say I was looking at this x plus 5. Remember, if there's not an exponent shown, it's a 1. But what would the leading coefficient be of that one? So basically, what number is in front of that leading term? And y'all, you also got to remember this. If I don't have numbers in front of my variables, I will treat it like a 1. So if you don't have a number in front of the leading term, it's got to be a 1. Right, another thing you're going to have to do in support is classify polynomials. And this is by the degree. So there's 5 of these. So the first one we call constant. Constant would be a degree 0. Example of a constant would be f of x equals 5. So it's always going to equal 5 no matter what. So notice, to be constant, it does not have the variable in with it. So that'll be a degree 0. Second one you got to know for support, linear. Linear is a degree 1. Example of linear could be f of x equals 3x minus 2. Remember, since there's not an exponent there, we would treat it like a 1. So that's how you get a degree 1. Degree 2 gives us what we call quadratic. For example of a degree 2 would be something like 2x squared plus 4. Highest exponent is a 2, making it quadratic. Degree 3, we call those cubic. So let's see, example of a cubic could be x to the 3rd plus 2x minus an x plus 4. And y'all, finally, a degree 4 we call quartic. Sort of like a quarter. Quartic is a degree 4. So let's see, I can have a negative 2x to the 4 plus 5x minus 7. Okay. So I'll show you an example of a support question. So they'll want me to give the find the leading term, lead coefficient, the degree and classify. All right, so y'all, let me move this down just a little bit for this problem. So say I had f of x equals 2x to the third plus 3x squared minus 5x plus 7. So the leading term then they want the lead coefficient, the degree, and then the type of polynomial. All right, so the leading term contains the highest exponent. So since my exponent that's highest is 3, my leading term will be the 2x to the third. My lead coefficient is the number in front of the leading term. So my lead coefficient would be the 2. My degree would be the highest exponent. Well, the highest exponent in this polynomial is a 3. So if you notice, once you got that leading term, you've got pretty much most of your answers. Now, for y'all, let me ask y'all this. What type of polynomial is that? Is it constant, linear, quadratic, cubic, or quartic? All right, so y'all got cubic, and it definitely is cubic. So that's the problems you're going to see in the support, okay? So now let's get into what college algebra is going to want to know about this. All right, so let me move my paper back up. So for college algebra, we're going to look at what we call the end behavior of the graphs. And y'all, I'm just going to show y'all on my calculator what I'm talking about on these. So let me pull up the calculator. So I'm going to go to my y equals, and I'm just going to plot x to the fourth. So I'm going to plot an x to the fourth graph. And then how about plus 3x minus 2. So I just want you to see this. So when I graph it, look at both ends of this graph. Both ends of this graph go up, just like a x squared graph does. Now watch this. If I change that exponent from a 4 to a 6, notice it's still even. So I'm going to change it to a 6 and show you on the graph. Notice it's still, both ends go up. So when you got even exponents, the big picture, both ends will go uphill. Or if you put a negative in the front, remember that will flip it over and make them both go downhill. So watch this. If I make that a negative x to the, so negative x to the 6, watch what that negative does to the graph. It flips it upside down where both ends go downhill. So even degrees will either both go uphill or both go down. Now, if I change that exponent on here to a 3, so now I'm using the, and I'm going to get rid of that negative for a second. So I've got an x to the third graph. When I graph that, notice it goes uphill left to the right. I can change that to x to the 5th. So now I got an x to the fifth. Want to graph that? It's still going uphill left to right. So the odd exponents go uphill left to right unless you put a negative in front. And remember that negative is going to reflect it over the x again. So if I put a negative in front, instead of going uphill left to right, it's going to go downhill left to right. Okay? So let's go back. So I wanted y'all to see what I'm talking about on end behavior. I'm actually talking about what the graph is doing as it goes out towards those infinities. So we can use a chart to figure out end behavior. Our chart, we look at the degree. So the degree can be even or odd. And then we compare the lead coefficient. And that lead coefficient can be positive or it can be negative. So that's going to give us a table with 4 different types of graphs. Remember, if it's an even degree, a positive lead coefficient, both ends will go up towards positive infinity. Now they leave a space in the middle because depending on how high that degree is, determines on how many turns are going to happen on the graph. Now, if that was a negative lead coefficient, it's going to take this graph and reflect it so that both graphs are sort of heading downhill, okay? All right, we said if it was odd and positive lead coefficient from left to right, it's going to sort of go uphill. And if that lead coefficient is negative, it's going to want to go downhill. Okay. So for our examples, they're going to give us a polynomial, and we got to determine which one of these pictures it's going to do in the long run. And y'all, what I'm going to do for this exercise, I'm going to label these A, B, C, and D. That way, when I ask the question, y'all can tell me, is it going to be A, B, C, or D for these answers? So this wants me to select the, select the sketch that describes the end behavior. All right, y'all. So for number 1, we're going to have f of x equals square root of 5 times x to the third plus 5x squared minus 3x plus 3. So y'all, what do y'all think the end behavior of this graph will be based on our table, our chart right here? And y'all, if y'all want, I'll do this one and then I'll let y'all do my next 2 or 3. How about that? So let me show y'all what I'm looking at. I want to know whether my degree is even or odd. And then I want to know whether my lead coefficient is positive or negative. So the degree is the highest exponent, which is 3. So 3 is an odd degree. The lead coefficient is that square root of 5 sitting in the front. Well, that square root of 5 is positive. So since my degree is odd, so here's my odd column, and my lead coefficient is positive. So positive and odd would give me picture B, so that this graph would go uphill from left to right. Y'all with me on that? I'm about to give y'all one of these. All right, for y'all are going to have P of X equals negative pi x to the sixth plus x to the fifth minus x to the fourth minus an x plus 1. So y'all, would y'all choose A, B, C, or D as y'all sketch? All right, so let's see. Raven said C, Mom said C, so let's see. So your degree is even. Lead coefficient is negative. So let's see, even and negative, C, good job. So that'll definitely be like C, okay? So y'all, the first, we like about the first 4 of them, we're gonna do this. So let me give y'all one more of these and see what y'all do. F of X is going to equal negative 4.5 x to the fourth plus x to the sixth plus 0.8 x to the seventh. So what y'all think on that one? A, B, C, or D? So it looks like I'm getting C's and B's. So let's see who's right on this. Lead coefficient and the degree of this one is a 7. So remember, watch out, they're out of order on some of these. So this one was out of order. So my lead degree is 7, which is odd. The number in front of that is a 0.8, which is positive. Well, let's see, y'all, odd and positive. So it looks like B on that one. Going uphill, left to right. Okay, y'all, so remember, the first term ain't necessarily the leading term. You got to put them in order of the exponents so that the highest exponent is your degree, and then this whole term is my leading term on that, okay? So remember, get them in order and then play with them. So I'm gonna have to give y'all one more of those, it looks like. F of X equals 7 plus 1 over 7 x to the fourth minus 6 over 7 x to the third. All right, A, B, C, or D. And I'll give y'all your choices back here. So both uphill, both downhill, going uphill left to right or downhill left to right. All right, so I'm getting some A's on here. So let's see. So my degree is 4 because 4 is the highest exponent. So that is even. My lead coefficient is the 1/7, but it's positive 1/7. So y'all look at that. Even and positive would be A. Good job. So both of these will go uphill, left to right. So that's the trick on those, is to figure out where that biggest exponent is and then start looking at that lead coefficient in front of it on its sign, okay? So the next thing they wanted y'all to do is to use substitution to determine if a number is a zero of a polynomial. All right, so about 3 steps on this. So first, substitute that number in for the variable. So everywhere there's an X, I'm going to plug my number in. Then I'm going to evaluate the expression. Basically, I'm just going to follow order of operations until I get a single answer. So here's the question I would ask y'all. If I plug a number into my polynomial, if it's a 0, what does the answer have to equal? And y'all let me remind. Okay, perfect. It's got to equal 0. Good job, Clara. That's why we set that quadratic formula when we was doing them. Remember, we set them equal to 0. So when you evaluate the expression, if the answer is 0, then the number is a 0 of that polynomial. And y'all, I think they only give you one of these. So this question wants to know, is 5 a 0 of the following? They give us f of x equals x to the third minus 12x squared plus 14x plus 105. All right, so we're really figuring out what f of 5 is going to equal. So I got to plug my 5 into this, and we need to see if that's going to give me 0 or not. So we would have 5 to the third minus 12 times 5 squared plus 14 times 5 plus 105. All right, so I'm just going to follow my PEMDAS stuff. No parentheses. I can't work inside the parentheses because all they got is the 5 in them. So next I'll hit my exponents. Well, I got 2 exponents. The 3 exponent affects that 5. The 2 exponent affects that 5. So 5 to the third, 5 times 5 is 25. 25 times 5 gives me 125. Minus 12 times what I get when I square that 5. Well, 5 times 5 is 25. And then I'm just bringing everything else down. So y'all, I've done my exponents. Now, we multiply or divide from left to right. Well, the only things I really got to multiply is the 12 and 25, and then that 14 and 5. So bring down that 125 minus 12 times 25 is 300, plus 14 times 5 is 70, and then at the end is my 105. So that takes care of my multiplying and dividing. So now I add and subtract from left to right. So 125 minus 300 is a negative 175. Negative 175 plus 70 is a negative 105. Negative 105 plus 105 gives me a big O 0. So since that evaluated to give me an answer of 0, that means yes, 5 is a 0 of that polynomial. So y'all, you'll have one to do of that. So questions on that. And remember, y'all got a calculator, so y'all can push it in the calculator just like this right here. It'll spit out a 0 quick. Also, I can show y'all a trick. Because remember, zeros are equal to the x-intercepts, right? So let me show you this on the calculator. I'm going to graph that x cubed minus 12x squared plus 14x plus 105 on my calculator and show y'all a trick. So let me go to y equals and clear that. So let me put that in there. I had x to the third minus 12x squared plus 14x plus 105. Now, I'll show you one thing. I'm going to graph that. So I'm trying to look at this. So they said 5. So go to the right 5. 1, 2, 3, 4. And look at that. That graph crosses right across that x-axis at that 5. So that's one way to tell me that, yes, it's a 0 because it crosses at that point. But if you go to the second graph to the table and go down here and find the x value of 5, at the x value of 5, look what you get. For the y value, you have a 0. So that's telling me any y value of 0, those x values are the zeros, okay? So I can arrow up. It looked like the other ones were to the left. So if I arrow up on my x's, all those other ones must have been fractions. Let me look at that graph. Yeah, so it looks like the one to the left would be a fraction and the one to the right. What I was worried about was that 5. So at x value 5, it did give me a 0, okay? All right, another way, plug that number in and make sure you get a 0 answer. All right, so for the next section, we need to learn more words. So this word is multiplicity. So when we're talking about polynomials, multiplicity is the number of times that a 0 occurs for the polynomial. Okay, It's the number of times that a zero occurs. Now, two more things that multiplicity tells me. If it's an even multiplicity, so for an even multiplicity, the graph is tangent at that zero. So tangent, so say, here's my x-axis and my y-axis. Tangent means that it comes down, touches the x-axis, and goes back up. So it does not cross the x-axis. It just comes down and touches it, okay? If it's an odd multiplicity, the graph crosses over the x-axis. So the graph crosses over the x-axis at that zero. So y'all, if this was my x and my y, my graph would come down and go through that x-axis if my multiplicity is odd. So even multiplicity, it comes down and touches it. Odd, it goes right through that x-axis, okay? All right, so let me show you some examples. And I'll show you how to find those multiplicities. So for these examples, they're going to want us to find the zeros of the polynomial. And state the multiplicity of each. So these start for y'all around number 6. All right, so let's see what we got. We got f of x equals x squared minus 4 raised to the 5th power. So remember this, the multiplicity is the number of times that a zero occurs for a polynomial. Well, this exponent 5 tells me that I would write x squared minus 4 5 times, okay? So the multiplicity is going to be given by the outside exponent. Now to find the zeros, I got to take each one of these factors, x squared minus 4. And if I want to find a zero, I got to set this equal to what? What would y'all set it equal to? Well, there you go. It got to be 0, right? And y'all, I think in this whole class, the only thing we'll ever set anything equal to is that 0. Now, 2 ways you can do this. That's an x squared on this one. So you could use the quadratic formula. So if you was to use the quadratic formula, A would be 1, B would be 0, C would be -4. The reason your B would be 0 on the quad formula is because there's not an X term in the middle. Remember, you got your X squared term, your X term, and then your number. But since this one don't have an X term on the quad formula, you have to put a 0. But that'd be the long way to do this problem. I'm going to show y'all how to solve this by taking square roots. And you can do this anytime you got an X squared term and a number. So the trick to taking square roots is you want to get the X squared term by itself. So to get the X squared term by itself, I add 4 to both sides. That way I get an X squared equals 4. Now to turn that X squared into an X, I'm going to take square roots of both sides. So what I do to one side, I do to the other. So I'm taking the square root of X squared. I got to take the square root of that 4. Y'all, the square root of X squared is X. What is the square root of 4? And y'all remember, since I had an exponent 2, you got to get me 2 numbers for this. So plus or minus 2, there you go. So my zeros are plus and minus 2. Each has a multiplicity of, so y'all, what's my multiplicity then? Remember, that would be my exponent. Where's that exponent at? Oh, go back to your main exponent. See, yeah, oh, there you go. It's going to be the 5. There you go. So you work inside the parentheses to find your zeros. You look at the exponents on the outside to get your multiplicity, okay? All right, so I'm going to start doing some more of these. So this one will be like number 7. Same directions. Find the zeros and the multiplicity. So this one has f of x equals x to the 4 times x minus 4 squared times x plus 8. And y'all, I'll tell you this. When you got a single variable like that x, that exponent is its multiplicity. The second parentheses, the x minus 4, its multiplicity is a 2. What is the multiplicity of the x plus 8 term? Because y'all, I don't even see an exponent on the outside of that. So good job. You would want to put a 1 there for that one. So you got 3 x's. We got to set each of these x's equal to 0 to find our zeros. We all look at that. And here's a rule for you. Anytime you got a single x like this, no matter what the exponent is, that 0 will be 0 for those ones, okay? So any single x's will have a 0 of 0. The next one, you would take the x minus 4 equal to 0. And the last one would be the x plus 8 equal to 0. And you really only got to do work when they're inside the parentheses. Like I said, 100% of the time, that 0 will be 0 for that single x. All right, so these two we need to work. So there's no x squared terms or nothing. So all I got to do is get the x's by themselves. So the first one, we're going to add 4. And that 0 is a positive 4. The last one, we'll subtract 8. And that 0 would be a negative 8. Because, right, those are the numbers. If you put a 4 in there, 4 minus 4, 0. You put a negative 8 over here, negative 8 plus 8, 0. So, y'all, here's the trick. The smallest 0 is blank with multiplicity blank. The middle 0 is blank with multiplicity blank. And then the largest 0 is blank with multiplicity blank. So of them 3 zeros, what is my smallest 0? Well, I got a 0, 4, and -8, y'all. The smallest number of those would be the -8. So the smallest of my zeros is -8. So what was the multiplicity on the one I got the -8 from? Well, that came from the factor x plus 8. And y'all told me since there wasn't an exponent there, it was a 1. So the 0 of -8 has a multiplicity of 1. The middle 0 is so the middle 0 is 0, yeah, because the middle number would be 0. Oh, now they're not talking about like first, middle, last. They're talking about the numbers, y'all. So -8 is the smallest one, 0 would be next, and then 4 would be my largest one. So the middle 0 is 0. What's his multiplicity? So that'd be a 4. Good job. Because remember, on the single ones, the actual exponent is its multiplicity. And then the largest 0 is, so y'all got a 4 there. And its multiplicity is 2. There you go. Okay, so exponents from a multiplicity, remember. Solve them to get those 3 zeros. All right, 1 like 8 has f of x equals -5, x minus 5 squared times x plus 2 to the 3rd times x to the 4th. Now, y'all, this one's a sort of tricky one because they threw that -5 out front. But there's no way in the world to turn a -5 into a 0 because there's no variable there. So since there's no variable there, we're going to cross that one out. You cannot get a 0 from a number like -5, okay? So you throw that one out, you're going to have 3 zeros. So y'all, here's the answers they do on this one. The 0, 5 has multiplicity blank. Blank is a 0 of multiplicity 3. And then the remaining 0 is blank. It has multiplicity blank. So really, if you want to, you can find all your zeros first by setting all the factors equal to 0. And y'all, once again, that single x gave me a 0 for it. The other 2, I got to add 5 to this one. So I get x is 5. And then this one subtract 2 in the middle. So I get x is a -2. So my zeros are going to be 5, -2, and 0. So here's their question. See what y'all put. The 0,5 has multiplicity of what? So I'm gonna go up 2, there you go, because I got that one from this one right here, right? And its multiplicity was 2. Check out this one. Blank is a 0 of multiplicity 3. So good job, that is definitely a -2, because it's the one that came from that multiplicity of 3. So the remaining 0 is blank, and it has multiplicity blank. So 0, 4, let's see. So there's 0, and it has multiplicity of 4. Good job. All right, y'all, so now comes the tricky one, okay? So this one says find the zeros of the function and their multiplicities. So I got f of x equals x to the third minus 5x squared minus an x plus 5. So y'all, the trick on this one, we got to get this one factored. Now, we'll tell y'all this. When they're not factored in this form, the highest exponent tells me how many zeros I need to have for this problem. So since that's an x to the third, I need to come up with 3 zeros. Now, once we get it factored, we'll actually be able to tell the multiplicities at that point, okay? So it's not factored. That's going to tell me I need 3 zeros out of this. So let me ask y'all this. Have y'all ever done what I call factor by grouping? Yeah, so it's sort of tricky, but I'm going to show y'all how to do this. So factor by grouping, you would take the first 2 terms and group together and the last 2 terms. So always group the first 2 terms together and the last 2 terms together. So the first thing you're going to do, so we group the terms. We're going to factor out the GCF of each terms. Or how about each group? So factor out the GCF of each group. So I need to find out what the greatest common factor for these are. And y'all, let me tell you a trick. The second greatest common factor always has the same sign as the third term. So since that's negative, that second GCF has to be negative. All right, so let's find the greatest common factor here. Well, that's a 1x third and a -5x squared. So they don't have no numbers in common. So I got to look at the variables. You got 3 x's here and 2 x's there. So the most they have in common is the x squared. Right, I got an x squared here and then an x squared inside that x to the third. So look at this. Here you got a -x and a +5. There's only one thing in the world they got in common. And that would be a 1. But remember, since that's negative third term, the second GCF would be a -1. So now, to finish factoring out the GCF of each group, you put that x squared followed by parentheses. You put that -1 followed by parentheses. So if you got the right GCF, these parentheses will match up once we divide by our GCFs. Y'all, let's see what happens. The x to the third divided by x squared, what will that leave us? That's going to be an x. And then it's minus, what's this going to leave me? 5x squared divided by the x squared. That's going to leave me to -5. So good job. So you divide the first two by their GCF. Now we're going to divide -x by that -1. So a negative by a negative is going to give us a positive x. Then look at this. That positive 5 divided by that -1 is going to make that a -5. So notice the parentheses now match up. So your next step would be to make 2 sets of parentheses. The stuff on the outside goes in one of the parentheses. So that's the x squared minus 1. So terms outside will make up one parentheses. The terms inside make up the second parentheses. So the x squared minus 1 was on the outside. I put that in the first parentheses. Since the x minus 5 matched up, they are now my second parentheses. And y'all guess what? At that point, we are now factored. Now, check this out. Since we're factored, I don't see no numbers behind these parentheses. So what number would go here and behind that x minus 5 parenthesis? Oh, not a 0, remember? Because remember, 0 would get rid of them. So let's see. Oh, I think it's on this side. Let me turn this page over. Oh, up here. When I started, I had an x plus 8. It didn't have an exponent, so we put a 1 there, remember? So technically, the multiplicities of both of these would be a 1. You got one of these factors multiplied by one of those factors. So remember, for multiplicities, you got to put 1s behind those. All right, y'all, so we're going to find our zeros. We're going to set each of our factors equal to 0. All right, if you want to use quad on this, quad would be 1, 0, since there's no x term, -1. But y'all, I'm just going to solve this by taking square roots. So I'm going to add 1 to both sides. X squared equals 1. Then I'm going to do square roots. And remember, since I'm doing a square root of a number, that's going to be a plus and minus 1. So that means 1 to 0, -1 to 0. The second one is not quadratic, so I'm just going to add 5. And I get x equals 5. So the zeros are x equals blank. Each 0 has a multiplicity of blank. So you would come in here, do 1, -1, and 5 for your 3 zeros. And then remember, each zero we said had a multiplicity of 1. Y'all don't worry, I got another one of those for y'all. So the trick is this, so y'all want to see a trick on this? I'm gonna go put this in my calculator. So watch this. If you don't like factor by grouping, come to your calculator, go to y equals. I'm gonna clear that out. I'm gonna put in my x to the third minus 5x squared minus an x plus a 5. So remember, if I want to know the answers, I can go look at what x values are giving me y values of 0. And let me show you the graph. So look at this. This is crossing the x-axis at -1. Well, that was one of our answers. It's crossing the x-axis over here at 1. That was my other answer. And then if you go out 1, 2, 3, 4, out at 5, it's crossing that x-axis again. So those would be the 3 answers: -1, 1, and 5. Now look at this table. Let me arrow down. So at -1, I got a 0 for the y value. At 1, I got a 0 for that y value. And then at 5, I had a 0 for that y value. So if you're weak at doing that factor by grouping, graph it and see where it's crossing the x-axis, okay? All right, so let me go back. I'm gonna do another one of these with y'all. All right, so for y'all, let's try this one. Same thing, this is like y'all's number 9. F of x equals 6x to the third minus x squared minus 96x plus 16. So let's group our terms. The first 2 we're going to group together, and the second 2. I'm going to factor out a GCF of each of these. Now remember, the second GCF has to be negative like that third term. So y'all notice once again, the only thing I can factor out of the first 2 is the x squared. But what in the world? Whoa, let's see what we can get out of that 96 and 16. So y'all see if I think 96 will actually divide by 16. If it's 32, yeah, so the second GCF will be a -16. And I think all these are designed, whatever that last number is on this one is going to be that GCF, okay? All right, so remember, we're going to set them up with our parentheses. And we'll know we're right because these parentheses better match up. So y'all, 6x to the third divided by x squared will leave me a 6x minus x squared divided by x squared is a 1. All right, -96x divided by -16 will leave you a +6x. And then 16 divided by -16 gives me a -1. So now my parentheses match up. So I'm going to write these as my 2 factors. The outside is the x squared minus 16. The inside is the 6x minus 1. So we're now factored. So what is the multiplicity of both of these factors? So definitely a 1. So remember, put your 1 there. All right, so that means take both our factors and set them equal to 0. All right, so the first one, x squared 2, again, so I'm just going to add 16 and do square roots. The quad would be 1, 0, negative 16. All right, y'all, so x squared equals 16. Now we're going to take square roots of both sides. So that's going to give me what, a plus or minus. Square root of 16 gives us a 4. This one, we're going to add 1, then divide by 6, because this one's not quadratic. So add 1. I get 6x equals 1. Divide both sides by 6. So that x equals a 1 over 6. All righty, so let's see. You put in your zeros. So the zeros are 4, negative 4, and 1, 6. Each has a multiplicity of 1. Now that one would be trickier on the graph, but I'll tell you a trick. Since you got a 6 in the front of this, if you want to see this 1 6 as a 0, let me show you what you would do on your calculator. All right, so I'm gonna go to y equals and clear that out. So I'm gonna put that polynomial 6x to the third minus x squared minus 96x plus 16. Now, I'm going to show you the table. On the table, you're only going to see 2 of these equal 0. That's that negative 4 is 0, and at positive 4 for that x, you got 0. But our table ain't broken up into fractions. So if we want this to show us that other 0, we got to go to second window and set our table. And we did this on problems last section, but where that says that triangle table, remember that's the change in the table. We call that delta table, which is the change. Since you got a 6 in the front, you want to make this a 1 divided by 6. You want the table to go by 6 instead of by 1s. Now watch when I go to second graph and to my table. There's my negative 4. So now you're going to get a lot more numbers down here. So I got a 0 at negative 4. I'm going to arrow down. I'm going to keep arrowing down until I find a 0. So that negative 1e negative 11, that's pretty much 0 to the calculator. So that 0.1667 would be what 1 6 is equal to. And then if I go down there to the 4, I'll have to keep going a little bit, get to that 4. There's that 4. Same thing with it. That e to the negative 11 is pretty much 0, because that'd be like 0.000000 all the way through. So either way, and then graph it. Look at the graph. There's negative 4. That second one in the middle is at the 1 6, and then the one on the right is at the positive 4. So it's trickier doing the graphing, but it will do it. All right, y'all. So I'm just going to ask y'all 2 more questions before I end it for y'all. True or false? If P of X equals x minus 9 to the 8th times x plus 2 to the 7th. Then the graph. Crosses the x-axis at 9, 0. So y'all, is that true or false? Does this graph cross over the axis at 9, 0, or is it tangent? So let me pull my chat up. So y'all are saying that's false. So let's see. So 9 would come from the first parentheses. It's got an even multiplicity. So good job. Since it's even, it's going to be tangent to that x-axis. So it would be tangent. All right, so I'm just looking at these exponents again. All right, try this one. If p of x equals x minus 6 to the 3rd times x plus 2 to the 10th, then the graph is tangent to the x-axis at -2, 0. True or false? I'm seeing a true up there because to be at -2, 0, you had to find this factor. It has an exponent of 10, which is even. So good job. Because we said if it had an even multiplicity, it was tangent to the x-axis. Okay, also that's 8.1. So let me give y'all some other info. So I sent out bonus for test 2. I sent that out for y'all, so just send that back. It's not due till the due date of that second test, which is what the 23rd, I think. So it's due by the 23rd. I sent out a study guide since I wasn't able to get on my portal at school. I sent y'all a worked out study guide for test 2. That was in your email earlier. Use that for the study guide. And if y'all still are having issues with the study guide, we will fix that Monday. I should have access back to my portal by Monday. So work that, see how y'all do on the study guide, and then we got to get y'all fixed for sure by Monday, okay? Let me see what else. Okay, so make sure y'all start signing up for your classes for the spring. Y'all are able to actually do that now. So we want y'all to do that, okay? All right, y'all, I'm trying to think. I have no more questions, so do y'all have any questions? Well, let's see. I'm not seeing any questions, so work your 8.1. So here's the thing. Remember, the study guide says it's due the 16th, but it let you work past that due date, okay? It'll let you work it all the way up to the test date. And it will not penalize you for being late on it. Okay, I just try to get y'all motivated on that study guide so that during the next week, so let's see, we got to complete both the assignments. So, are you talking about since I sent 2 problems on that one sheet? Oh, no. Okay, so here's the thing. I got 2 attachments. One attachment is in what do you call Word form? And the other attachment is in PDF form. I do both of those because sometimes people can't pull it up in Word, but they can pull it up in PDF. So whichever version you can work that and send me back, okay? All right, y'all, so let me start my recording.